Welcome back to my channel Electronic Science Tutorial. Today is the 17th class of Operational Amplifier. Today I will discuss the non-inverting comparator circuit by using an op-amp. So without any time waste, let's start our class. So what is non-inverting comparator circuit proper definition? That is, a non-inverting comparator using an op-amp is a circuit where the input voltage is applied to the non-inverting input terminal of the op-amp. Comparator circuit means the circuit which can compare the two voltage level. So, one input voltage we applied at the either non-inverting terminal or inverting terminal. In this case, for non-inverting comparator circuit, the input voltage is applied at the non-inverting input terminal of the op-amp and the reference voltage is applied to the inverting input terminal. Okay, the output of the op-amp will swing to either positive or negative saturation voltage depending on the comparison between the input voltage and the reference voltage. So this is the proper definition of non-inverting comparator circuit. That is, a non-inverting comparator circuit using an op-amp is a circuit where the input voltage is applied to the non-inverting input terminal, that means the positive terminal of the op-amp, and the reference voltage is applied to the inverting input terminal, that means the negative terminal of the op-amp. The output of the op-amp will swing to either the positive or negative saturation voltage depending on the comparison between the input voltage and the reference voltage. Okay, so this is the non-inverting comparator circuit concept, right? This is the circuit diagram of non-inverting comparator circuit. As I told earlier slide, that is, the reference voltage is applied to the inverting input terminal. This is the inverting input terminal, that means the negative terminal, and the input voltage is applied to the non-inverting terminal, that means the positive terminal. VCC is the power supply of the op-amp. VCC is the positive power supply which is applied to the op-amp, that is plus 12 volt or plus 15 volt. VEE is the negative power supply that has been also applied to the op-amp. The value is minus 12 volt or the value is minus 15 volt as we applied. Okay, and V0 is the output terminal. So this is the circuit diagram of non-inverting comparator where we applied reference voltage at the inverting input terminal and the input voltage at the non-inverting terminal, and from this input voltage is compared with this reference voltage. Okay, so how this works, we talk about this topic in next slide. Okay, so this is the circuit diagram of non-inverting comparator circuit. What is the working principle of non-inverting comparator circuit? That is, here we consider two conditions. One is the input applied voltage which is applied at the non-inverting terminal, that means the positive terminal, and the reference voltage that is applied to the negative terminal or the minus terminal or the non-inverting terminal, that is the reference voltage. So two condition arises. One is applied input voltage is greater than reference voltage, that means the non-inverting voltage level is greater than reference voltage. Okay, so what will be happen in this condition? First of all, the voltage at the non-inverting input is greater than the voltage at the inverting input. This condition arises, that is V in greater than V reference. When this condition arises, we get the output of the op amp swing to the positive saturation voltage, that is plus VCC. Okay. Next condition what will arise when V in less than V reference. That means when the non-inverting input terminal voltage is less than the reference voltage. That means the inverting input voltage. So what will be happen? The voltage at the non-inverting input terminal is less than the voltage at the inverting input terminal. And in this situation, what will be the output? The output swings to negative saturation voltage, that is minus VCC or minus VEE. As we saw in the previous slide, that positive supply is referred there plus VCC and the negative supply is referred there minus VEE. So we can consider it as minus VCC or minus VEE, any of these. Okay, so the output of the op amp V out swings to the negative saturation voltage, that is minus VCC. So this is the working principle of non-inverting comparator circuit, where the two conditions arises. One is V in greater than V reference, that means the non-inverting comparator input voltage is greater than the inverting input voltage, and then the V out swings to the positive saturation voltage and it gives positive VCC. And the second condition is when V in is less than V reference, that means the non-inverting input voltage is less than the reference voltage, that means the inverting input voltage, and then the V out swings to the negative saturation voltage, that is minus VCC or minus VE. Okay, that gives the negative saturation voltage. So we get either minus VCC or we can represent it as minus VEE. Okay, so this is the working principle of non-inverting comparator circuit. The graphical representation of non-inverting comparator circuit is look like this. So how it will be described? That is, this blue line is for input voltage. That is the non-inverting input voltage, V in. This green dotted line is referred the reference voltage, that is V reference, which is applied to the inverting input terminal. And this red line, that is the output voltage, which we get from the V0, okay, from the output of the op amp. So this blue line, when first of all this blue line is a sinusoidal wave, this blue line is a sinusoidal wave. So and this dotted green line is the reference voltage, which is throughout the system it is because it is represented as a reference voltage, so it is a constant level voltage. Okay, so throughout the system reference voltage is a constant voltage and input voltage is a sinusoidal voltage, which is represented by this blue solid line. Okay, now the two condition from the working principle of the non-inverting comparator, we saw the two condition arises. One is V in greater than V reference and the another condition is V in less than V reference. That means when input voltage is greater than reference voltage, that means this condition. This is the reference condition, reference voltage, and this is the input voltage. So when V in is greater than reference voltage, we get the positive VCC. That means we get the positive plus VCC output. So this red color square wave, we get this red color graph. That means this is the red color graph. How long this red color graph is located? That is as long as V in greater than V reference. Okay. In that time when V in less than V reference, that means this is the time, that is V in less than V reference, then what will be happen? Then we get the negative swing voltage, that means the minus VCC voltage. So this is the red color graph time period. Again, how long it is situated in this situation? That is as long as when V in less than V reference. Whenever V in is greater than V reference, again the red color graph is positive. We get the positive output, that means VCC plus VCC. As long as V in greater than V reference, the red color graph is also in the positive axis. Whenever V in less than V reference, the red color graph again swings to minus VCC. Okay, that means when we compared two voltage level by using an op-amp, we get one square wave output. We applied at the input voltage a sinusoidal voltage. We applied a DC voltage, we applied a sinusoidal voltage at the input voltage, that means at the non-inverting terminal, and a reference voltage at the inverting terminal, but from the output we get a square wave output. So by using comparator we get a square wave generator, or we will get a square wave output. Okay, so this is the graphical representation of non-inverting comparator circuit. Whenever V in greater than V reference, this red color line is in the positive axis and it is constant in this situation. When it switches to V in less than V reference, that means this condition, then it swings to minus VCC and we get this situation. Again it swings to positive VCC, that means when V in greater than V reference, and we get the positive VCC. Again we get the negative VCC condition, that means when V in less than V reference. So in this way we can compare the two voltage level. Okay, so this is the non-inverting comparator circuit graphical representation. I hope you understand this topic, and by using this graph, by using the working principle, you can uh, easily understand the non-inverting comparator circuit. Okay. Thank you. If you like, do like, share and subscribe my channel.